So for each attribute, we have to look at for attribute value, assign the most frequent class. When you look at sunny, we have seen the outcome is no, 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 yes, yes. The most frequent class is no. And out of 5 instances, there are 2 with yes, so that's the error rate when sunny is no. Similarly, when you look at overcast, you can check the outcome. Yes, we have overcast, outcome is yes. Again overcast, outcome is yes. We have here 2 overcast, overcast, outcome is yes and yes. What is the most frequent class? Yes, that's yes. So the most frequent class is yes. What is the error rate? Error rate, there's no error. All the 4 instances, we have 4. Out of 4 instances, no errors. All the instances classified as yes. Let's look at the third one. Right, that when we have rainy, can you tell me what is? Yes, rainy. When it is rainy, we have 3 instances here, and we have yes, yes and no. Then again we have rainy here, again yes. Last one also we have rainy, we have no. So that means we get yes, yes, no, yes, no. What is the most frequent class? Most frequent class? Yes. And the error rate is yes. Out of 5 instances, how many errors? There are 2 no's, right? So this is the error rate. So now we can calculate the total error. The total error is out of 14 instances, yes, 2 by 2, we will get 4 as the total error for Outlook attribute. For Outlook attribute. It's a simple idea, right? So we have done for one attribute, right? We first selected Outlook. We went through all the attribute values. So we had 3 values: sunny, overcast, rainy. And for that we look at most frequent class. For sunny, most frequent class is no. For overcast, most frequent class is yes. For rainy, most frequent class is again yes. Error rates were calculated separately for the 3 rules, and finally we add them up to get the total error. Understood the first one? Yes? Right. Okay. Now it's your time. Do this the same procedure for temperature, humidity and wind. Okay. So now we are going to do the same process. What is the same process? For temperature. How many values are there for temperature? How many values? There are 3 values. So each of these different values, find the most frequent ones. Find the error rate. And all the error rate for the 3 values and put it as a total error. Okay, you don't have to do this hand. Software will give you the answer. But to understand what is happening, we are doing this, right? When there's a tie, that means you have 2 no instances and 2 yes instances. Which one you are going to select? Yes? Which one? If you have a tie, what are you going to do? Yes? You can take either one, right? Randomly. Usually when we have ties, all these machine learning algorithms, most of the time, we solve these ties by randomly. If you have equal, number of no's and yes, you can either take no or yes. But usually we look at the class of other rules. Now let's say we have 3 rules, 2 of them as no, and the other one is a tie. Usually we take as yes to match both classes. So I'll come to that later on. So let me show you. We'll go back, try to calculate. Right, the second one is temperature. We want to get temperature. And temperature, we have 3 different values. We have hot, we have mild, and we have cool. Right, now we have to find most frequent class for hot, most frequent class for mild, most frequent class for cool. Right, so for hot, right, what is the most frequent class? We have 2 no's and 2 yeses, right? Is that so? When you look at hot, the outcome is no. Again hot, outcome is no. Hot, it's yes. Then when we have the last one, hot, it's again yes. So 2 no's and 2 yeses. You can either use no or yes, doesn't matter, but make sure that you balance the classes. So I'll come to that point later on. So right now I'm going to choose no, but you can also use yes. So if I put no, what is the error rate? Yes, out of 4 instances, 2 is the error. Now we look at for the mild. So it's yes, no. We have 3 here. We have yes, yes, yes. We have no when it's mild. So that means we have yes, no, yes, 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 no. We have 3, 4, 5, 6. So we have yes is the most frequent class, agreed. And the error is there are 2 no's out of 6. Similarly, go for cool. So cool, we have yes. Cool, we have no. Cool, we have yes. Cool, we have yes. That's all. We have 4. When you have 4 instances again, we have yes, no, yes, yes. So most frequent class is yes. And the error is yes 1, isn't it? Yes. You have 1 no instance, others are yes. Right. So the total error is we have 5 divided by total number of instances, that is 40, right? Now remember the first one, it could have been no or yes, but if you put yes, everything is yes, right? In a situation like this, we try to balance both the classes, so we prefer no here. But in your case, if you even put yes, doesn't matter, right? Because this is random. Right. Okay. So if you have done this way, you should get this answer. If you are not finished, don't take down this answer. But you can try that too. Right? But save some time. Now I am giving you the rest. Okay. Now we have how many rules? How many rules? For the 4 attributes. For the 4 attributes, we have, this is a rule set. For Outlook, this is a rule set. Temperature, this is the rule set. Humidity, this is the rule set. Windy, this is the rule set. Now once we calculate all the total error rates, right, we need to find rule set with the least error, right? Choose the rules with the smallest error rate, right? If you go back, which one has the least error? Yes? If you look at the least error, which one has the least error? Is it Outlook, temperature, humidity or windy? Yes? Is it Outlook? And? Windy. Again, we have 2 sets of rules. Which one you are going to select? Which one? Again, like I said, you can make it random. You can either use Outlook or humidity. But normally, software will give you only one answer. So, basically, you will get outcome like this. And this is our data model. Right? This is our data model. Whenever we want to play the game, we look at the weather conditions. And we are going to look this rule set. And this rule set has only one attribute, which means you don't have to look for other attribute. Just look at the Outlook when the outlook is sunny, are you going to play the game or not? No, you are not going to play. Overcast? Yes. Rainy? Yes. I don't know what kind of a game it is, right? But anyway, that's what the data tells you to do, right? When sunny, when outlook is sunny, no, don't play the game. It could have been a board game, right? We don't know, right? Overcast, yes, rainy, yes. So that's what this data model tells you. But remember, we got this model from the data. You input the data, and it tells us, okay, this is what you should do whenever you need to play the game. Very simple one, but I think you have understand the whole process, starting from the data, how you end up in getting this, right? The next one, I will show you this in two software packages. First one, what I used to teach last time. Second one, we are doing Python. In Python, how we got this, but using the same idea, right? So I'm going to use, first of all, there's a software called Weka. Weka is actually developed by a pool of researchers from University of Waikato, New Zealand, and it has a simple interface like this, and then you can use it to open data sets, right? So I'm going to find this data set. It's in C, inside the program files, inside Weka, inside data, and our data set is weather data set. You can look at the data set. This is the same data set that you have used. Yes, agree? This is the same data set? Okay, right. It's the same data set. Now we are going to make a classification. I told you about the 0R before 1R, right? What we learned is 1R. Now 0R is just gives you the majority. Just look at the class attribute. What is the majority class in this data set? Majority class means you count the number of yes and no classes, whichever the most frequent one is called the majority class. So is it yes or no? Yes? Somebody asks you whether to play that particular game or not from you. Your answer could be either yes or no. But if you just look at the data, if you don't know anything about the data, instead of randomly say yes and no, we can say most frequent class. So that is what the 0R does. So when you use 0R, when you say start, right, 0R predicts the class value yes. You got that? 0R predicts the class value yes. That means the majority class is yes. That's what it says. So even if you have millions of records, now you have only 14 instances, you can count by just by observing. But if you have millions of records in your database, if you apply 0R, it will gives you the majority class. What we have learned is 1R. So I'm going to select 1R. It comes under rules. Okay, 1R. Let me run. Right, and here is the outcome. Classifier model, outlook, it says if the sunny, then it says no. Overcast, it says yes. Rainy, it says yes. 10, 14 instances correct instead of error rate, it says that. Got the idea? Now we have learned one algorithm. We learned how to make it by hand. We don't have to do this. We had only 14 instances, that's why we did it. But you could have used in this, right? Okay. But for you, this time I'm not going to use this one. I'm just showing you. we are going to use Colab. So, and under the Colab, we started last time using notebooks, and you are very familiar with the basics of Python, right? Okay, I'm wondering where my notebook is. It should be something to do. Okay, Python Weka. Right now you might not understand anything at all, right? So these commands you don't understand. There's no way that I don't think, except you, if you already know Python, you don't understand what is happening here. But we discuss these things later on. Once we learn these things, right? 0 R predicts the class value, yes, we'll get the same answer here as well. And when you have 1 R algorithm, you can see it's only 4 lines of code we use to get the answer for this, and you are getting the outcome, right? I just showed you in True Software, but actually Python also uses the same Weka software inside to get this set of rules, right? Okay, so have you understood 1 R now? You know what is happening? Good. Right, we can move on to the more about this. Right, so I'll go back to the slides again. Now we have understood, given a data set, how algorithm give us a model, something you can use to make prediction, isn't it? Now whenever you get a new weather condition, you don't have to go through the data set, you can just look at this. You can give the outcome, right? Okay. Now I'm going to make it a little bit harder. You might think that this is easy. No, it's not easy. Things get more difficult when you have, like, for example, mixed attributes. What do you mean by mixed attribute? Our previous data set, we had only nominal, categorical data set, isn't it? Outlook, sunny, overcast, rainy. Temperature, right? Normal, high, low, cool, right? But normally we have numerical value. So let's see how we are going to handle numerical attributes or mixed attributes with 1 R. Why we are going to look at this is the same thing applies to more complex ones. So if you understood how this happens with a very simple algorithm, then you can easily understand it with the complex attributes. Right. When you have a numerical data, how do you find ranges? Now you are in, I don't know, you are doing following from your experience. Can you tell me? We have salaries. How do you make a scale? Like group them. They usually group them, isn't it? No? Yes? You are grouping this. Why? Why not just the numbers? Why groups? Yes? Okay, it's easy to analyze. Okay. What else? If you wonder why you are analyzing, in my case, I'm not about, I don't know about finance a lot. But in my case, the problem is my algorithm needs ranges. Right. So in my case, because in the previous one we have said outlook, sunny, rainy, overcast, with me some kind of a ranges that we have. So numerical value I cannot use as it is for these algorithms, so we have to make ranges. So usually we say this is discretization. Discretization means we find some intervals in the data set. Right. So from your, before I teach my one, how do you like make ranges? You have different salaries, let's say 10,000, 13,000, 25,000, right? And most cases say 1 million. Starting from there. So how do you make the ranges? Is it arbitrary or is it based on some theory? How do you do that? I'm just curious to know how you do. Before I explain how I do in this area, how we do. Yes? Yes, maybe you sort it out. Yeah, okay. For example, in this case, we have salaries and then you spend money. How frequent is? For example, one person getting 1 million, say 50% of this they are getting 10,000. So how do you do? Are you going to use equal numbers? So you have some time. Good. Now, in our case, we know that these values attach with some class label because we have numerical value and we have class label. Something we need to predict. We look at how value changes. Right. Okay. So what we are going to do, we sort the instances. Temperature from lower temperature to the higher temperature together with the class label. We look at the attribute and the class label. And then we make breakpoints whenever the class changes. When class goes from more to just, we know that here something changes, so we make a break. Right? And then we try to minimize the total error. Right. So let's look at how we could do this. Now here is a new data set, mixed data set. So now you can observe it's the same data set, but for temperature and humidity, now we have numerical values. Right? I will show you how we do this for temperature. Now for temperature, we will sort the values. The lowest temperature is 64 if you go through this. Yes? Highest temperature value is 85. Whenever the class changes, we put a breakpoint. Then you might wondering why there's no breakpoint here. For the same value, we cannot have two different classes. So that's why we have not put a breakpoint. Other than that, whenever class changes, we put a breakpoint. Right. But don't you think we have too many intervals, isn't it? If you put in this way, we have too many intervals. Right. If you follow that, this is very sensitive to noise. Noise means the class value changes very frequently. It tends to give us errors. Right? If you have one incorrect label, when you have data, you know that there are sometimes we have erroneous data. We made mistakes. So one error will mean that it's a separate interval. So which means what we were trying to do earlier, it's not going to work. So we have a simple solution for this. We specify minimum number of instances. Now when you make interval, we say, okay, at least you have to have 3 minimum instances from the majority class. So that we are going to reduce number of intervals. We enforce minimum number of instances majority class per interval. Right. So we are going to say, now earlier, in previously, we have only one instance here. Here we have 1. Here we have 3. Here we have 3. But from majority class we have only 2. Right? So it goes along like this. Now what we are going to do is, we are going to say, okay, in the interval, at least you have to have 3 minimum instances from the majority class. Right. If you specify the minimum 3, what will happen? Right? You start from here. Yes, you start from here. It's yes. You have to remove this one, isn't it? Because we don't have minimum 3. Criteria is not met. We will remove this breakpoint. Now you come to this point. Again, you have only 2 instances and 1 from each. So you remove this one as well. Got the point? We start with putting break for each different classes. Now we are going to specify minimum 3 instances of majority class. Now you can see 1, 2, 3, 4, 5. And majority class we have yes. How many instances? We have 4 instances, which means it satisfies our criteria. So we are going to keep this separation. Okay. Next we start from here. We have 1, 2, 3. Majority is 2. So that means we have to remove this one. Now we will get 1, 2, 3, 4, 5. Out of 5, 3 coming from yes. That satisfy the minimum criteria. So we are going to keep this one as well. Next, we'll look at the other ones. We have no. One instance, we'll remove this one. Yes, we'll remove this one. Anyway, this is the end. We'll keep it as it is. Now, what is the majority here? So, what is the majority from this interval? Majority class from this interval? Yes, right? It's yes. We have yes. What is the majority class of this interval? Again yes. What is the majority class of this interval? It's a tie. You can either take yes or no. Which one is better? Since we have yes and yes, we have to have a representation for the other class. So better to use no here. Right? We'll take no. Now there's an issue. So you have the same class. Do you need this breakpoint? Do you need this breakpoint? Because up to this one also yes. This is also yes. There's no point of having this breakpoint. So we can remove this one as well. Now, so up to this point, we can get it as majority as yes. And after that we can get majority as no. So we end up with 2 intervals. We end up with 2 intervals. What is interval? We check whether the temperature value is yes. Temperature value is, how do you define the interval? Less than or equal what? These are the 2 values, 75 and 80. What is the middle point? 77.5. It's a middle value. So we say if the temperature value is less than 77.5, yes, then it is yes. If it is greater than 77.5, we say it's no.
If it is beyond 76, it's no. It is under 75 is yes. Let's say if it goes beyond 75, it's a no.
No, we can say that usually when we have a midpoint between 75 and 80, 75 is saying yes, 80 is saying no. We don't know where this happens. This would be take the middle point, and we are going to say if it is less than the middle point, then it is no. Beyond that, we will say less than the middle point, yes. Beyond that, we will say no. We usually get the midpoint.
Right. Now you can see, right, we can find temperature value if it is 77.5 less than, we can say if the temperature is less than or equal 77.5, we can say the class is yes. What is the error rate? What is the error rate? Go back. What is the error rate? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Out of 10, we have 1, 2, 3, right? We have 3 errors. So we have 3 out of 10. If it is greater than 77.5, yes, we are going to say no. And the error is, we have out of 4 instances 2 errors. What is the total error now? Out of 14, yes, 5 is the total error. Got the point? Yes. Okay. Now next part is for you. Do it for the humidity and find the total error. So do it for the humidity. So this data set I have to give you. So I will be going back to the data set. Do you want to take this down? No, right? I don't know. So the table, this is the same as the previous table. This is the same as the previous table. Outlook and windy, they are the same, no changes. But the temperature, we had numerical values. Humidity also we have numerical values. Okay, so I go back to the data set. Here is the data set. Now you have to work on humidity. What is the first step? What is the first step? First step. For humidity, now we are going to do. Yes? What is the first step? We have to sort humidity values together with their class values. Right. Shall we do together? So what are the values we have? We have 85, we have 90, 86, in 96 we have 80, we have 7. Okay, I think we better go with the class later. 85 no, 90 no, 86 yes, 96 yes, then 80, again yes, right? 70 no, if I make a mistake tell me. 65 yes, then 95 it's no, right? 95 it's no. 70 again 70 yes, right? We have 70 yes. Then 80 yes, again 80, right? 80 yes. 70 yes. 90 yes. 75 yes. 75 yes. 91 no. We have 91 no. Right, I will make it clear. We have 65 yes. 70 no. 70 yes. 70 yes. 75 yes. 80 yes. 80 yes. 85 no. 86 yes. 90 no. 9 yes. 91 no. 95 no. 96 yes. So this is the first step. What is the second step? You sort the all the numerical values to get their class values. So I got all the values, check with their class label in a sorted manner from lowest humidity value to highest humidity value. What is the next step? We put a breakpoint whenever the class changes. So just to know, we can put a class breakpoint. Note, yes, we cannot put a breakpoint here because you have the same values, right? Then we have yes, no, just a breakpoint, right? No to yes, another breakpoint, yes to no, another breakpoint. But you cannot take breakpoint here, right? Then again you will have breakpoints like this. So the next step, whenever the class value changes, we make a breakpoint. Here we cannot put a breakpoint because you have a same value, so after that you put a breakpoint. We have yes, breakpoint, no, breakpoint, yes, breakpoint, no. You can put a breakpoint here, you have the same values, breakpoint. Then we have no, you have breakpoint. If you have too many intervals, what is the problem? Too many intervals. It's try to represent your data as it is, which is not good. So we need to simplify this. So if you specify minimum from the majority as 3, yes, can you tell me what is the final interval you are getting if you put minimum as 3? Yes. Did you get the interval when you specify minimum 3? Yes. Minimum 3 is a parameter. That means we have to decide how many we are going to keep. Now, right now the problem is this is too many intervals. Are you agree with me? Right? It's too many. We want to simplify. So when you want to simplify, the idea we are going to use, we are trying to specify minimum number of instances. Now right now I put as a 3, but you can say 4. If you learn the parameters of this algorithm, that is a kind of a parameter that you have to use. So we have to actually identify whether we are going to select 3 or whether we are going to select 4, whether we are going to select 9, it's up to you. Right now, we are going to say it's 3. Right. So if I say 3, now we'll count. Anyway, we have to remove this. Right. Now we have 1, 2, 3. 3 from the same class. We can keep this, isn't it? Yes. Now from here, 1, 2, 3. Again we can keep this. Then we have 1, we have to remove this. 2, we have to remove this. Now we have 2 and 2, we have to remove this. Now how about? We have 1, 2, 3, 4. Okay, this is we can keep. And finally we have, yes, we have left with 1, we have to keep it as it is. Right, now we look at the majority class. So this is yes, this is yes, this is no, and this is yes. So since you have yes and yes, we can also remove this one. We can say up to this point we have yes. what is the interval now we are getting? So how do you make the rule now for humidity? So for humidity, what are the intervals? Humidity, if the value is between 80 to 85, that means what is the midpoint? This is yes, this is no. So midpoint is 82.5, right? So how do you get 80 plus 85 divided by 2, 82.5. So we say if the value of humidity is less than or equal to 82.5, what is the rule? What is the rule? What is the rule? What is the majority class? Yes. When the value is greater than 82.5 and what is the midpoint here? 95.5 and less than or equal 95.5, what is the rule? Between here to here, the most frequent class is yes. It should be no, right? This is no. Then the value is greater than 95.5. What is the frequent class? Again, yes. So what is the error rate here for this rule? What is the error rate? What is the error rate here? How many instances? 1, 2, 3, 4, 5, 6, 7. Out of 7, we have 1 error. So this is 1. And here, what is the error? We have 1, 2, 3, 4, 5, 6. Out of 6, we have 2 errors. Last one. What is the error? Yes, no errors, right? We have only one instance, it classified as yes. So no errors, meaning 0, 1. So what is the total error there? What is the total error? Yes, we have a so this is what we get for humidity. Now tell me, for the numerical data set, what is the final outcome of 1R algorithm? What is the final outcome? Which attribute has the lowest error rate? Is it outlook? Is it temperature? Is it humidity? Yes? Yes? So if you are done it, yes, which one has the lowest total error rate? Lowest error rate is humidity. Right. Now let me show you this answer with the software. So here is the Weka interface. First of all, I have to open the numerical data set. So numerical data set is weather numeric data set. Right. Can you confirm that is it the same data set? Is it the same? Hopefully, right? Okay. and then we go to classify. We have to say 1R. Okay, so you see here there's a parameter B, right? If you click it, right, if you say more, minimum bucket size, meaning minimum number of instances, we can specify it here. Right now it's 6, so I'm going to make it to 3 because we have decided to use 3. If you use 3 and if you run, here is how we got the data, right? So humidity, whenever the value is greater than 82.5, it's yes. Then after that, if it is less than 95.5, then it's no. Then again greater than or equal to 95.5, again it's yes. So you don't have to do this in manually like what we did now, but why we did it? To understand how the algorithm works. So now you can use any other data set, right? So let me try to open some other data set. Okay, diabetes, let's see. Okay, so we have a set of numerical data with class, and if you apply this to same, right, here is how we are going to get the outcome. Okay, so I hope now you see. If you understood how the algorithm works, then you can use the software to do this for you, right? Now let me show you this in the Python code as well. Again, this is the numerical data set in Python, and then we are using 1R algorithm, and we set minimum number of bins, or the frequent class is 3, and when you define it, you are getting this final answer as the final one as humidity, and with this rule set. Now whenever you get a new data point, now what you have to look at is only the humidity attribute. When the humidity attribute, if the value is less than 82.5, then you are going to play the game. If it is less than 95.5, which means if it is greater than 82.5 and less than 95.5, then you are not going to play the game. If it is greater than or equal to 95.5, then again you are going to play the game. So 1R again, right? If you look at back what we did, it's a very simple algorithm which assumes, right, which assumes that one attribute is enough, right? If I go to the previous one, right, so the idea behind this 1R is one attribute does all the work, and that's what we are going to do with 1R algorithm. So we are going to find the best single attribute which performs the classification, right? So quickly what we did is, for each branch, one branch for each value, for each branch you assign most frequent class, and you calculate the error rate, and then you finally choose attribute with lowest error rate, right? And this is what we have done. Any questions? No questions? Understood everything? No? Okay, let's see. Are you ready to learn the second algorithm as well? What is the time now? 8:20. 8:20, right? We have 10 more minutes. Then we have the game then. Quiz. But we have the quiz now. Go after quiz. We have after quiz. So we'll have a early break there because I'm going to teach
decision trees. So let's have a break now. That means 10 minutes early. So you have to come back again 10 minutes early, right? Okay, we'll have a break, and after break we'll continue.